One day, the stars will go out and the universe will fall silent. We think we are winning, but time has already defeated us. This is the terrifying reality that no one wants to face. The last light. What if we actually make it? What if we survive everything the universe throws at us? The asteroids, the pandemics, the wars, whatever the filter is, and we actually become a spacefaring species? What if we spread across the galaxy and then beyond it? Does the story end well? Here's the thing. The universe already has an answer to that question. It's been working on it for 13.8 billion years. And it's not the answer you'd hope for. Okay, so stars don't last forever. You probably knew that. But I don't think most people have really sat with what that means at scale. The biggest, brightest stars burn out in just a few million years. That sounds like a long time, but on cosmic timescales, it's basically nothing. A camera flash. Our sun is more modest. It's got maybe 5 billion years left. And then there are red dwarfs, tiny, dim, almost embarrassingly low-energy stars that will keep burning for trillions of years. Trillions, not billions, trillions. Cosmologists call the era we're living in right now the Stelliferous Era, which basically just means the time when stars exist. It'll last something like 100 trillion years. We're less than 14 billion years in. We're early. But it does end. Eventually, no new stars form. The ones that are left slowly cool and fade. And then something happens that's hard to even picture. The long darkness begins. A universe with no stars, no light, just cooling remnants and silence. This isn't a guess. It's what thermodynamics predicts, pretty much without any wiggle room. The universe is winding down. It has been since the beginning. The only real question is what, if anything, is still around when it gets there. Here's where it gets strange. Because when the last star dies, the universe doesn't just go black and stay black. Things are still out there. They're just not things we'd easily recognize. What's left are what astronomers call stellar remnants, white dwarfs, the compressed cores of dead stars, roughly the size of Earth, incredibly dense, no longer burning, just slowly bleeding heat into the void. Over hundreds of trillions of years, they cool. And eventually, in theory, they become something called black dwarfs. Cold, dark, inert. Just mass, drifting in nothing. Here's a weird detail I love. We don't think any black dwarfs actually exist yet. The universe hasn't been around long enough for even the oldest white dwarf to cool all the way down. So every black dwarf is still in the future. They're objects that don't exist yet, in a universe that technically already does. And then there are black holes. Black holes are almost offensively patient. They outlast white dwarfs, neutron stars, everything. For an incomprehensibly long time, they're the only significant structures in the universe, slowly consuming whatever drifts near them, ruling an empire of emptiness. But even they don't last. Stephen Hawking figured out that black holes slowly leak energy, a process so gradual it's almost impossible to imagine. The biggest ones will take something like 10 to the power of 100 years to fully evaporate. That's a 1 followed by 100 zeros. Written out, the number is longer than this paragraph. When the last black hole finally goes, that's it. that may genuinely be the last thing that ever happens in this universe. After that, time keeps moving, but there's nothing left to move through it. So here's the question I find myself stuck on. Could anything actually survive all of that? Not bacteria in a rock. Not anything biological, obviously. We're talking about a universe with no stars, no warmth, temperatures approaching absolute zero. But what about intelligence in some form? Something that processes information, that adapts, that in some meaningful sense continues to exist. A physicist named Freeman Dyson thought about this seriously in the 1970s. He asked whether an advanced civilization could, in principle, survive forever by essentially rationing its existence. Slow down, hibernate, use tiny amounts of energy, wake up occasionally to think and act, then go dormant again. His conclusion was cautiously, yes, maybe. It's a strange and beautiful idea. An intelligence so old it no longer really experiences time the way we do. Waking up every billion years to check in. Slowly thinking thoughts that take geological eras to complete. But later physicists found a problem. Dark energy, that mysterious force driving the universe's expansion, creates boundaries. Regions of space that become permanently cut off from us as the universe grows. Resources that were theoretically available become physically unreachable. And at some point, even a perfectly efficient intelligence runs out of things to draw on. We genuinely don't know how this plays out. The physics of the very far future is extrapolation stacked on extrapolation. But the direction of it is clear. The longer you wait, the harder it gets. The universe is not designed for long-term tenants. Heat death is one of those phrases that sounds dramatic, but is actually describing something quieter and stranger than any explosion. It doesn't mean the universe overheats. It means the opposite. It means the universe reaches a state of perfect, boring sameness. The same temperature everywhere. No hot spots, no cold spots, no gradients at all. And here's why that matters. Without a difference in temperature, you can't extract any work. You can't move energy from one place to another. You can't do anything. Everything we experience, light, heat, life, thought, depends on differences. Hot and cold, high energy and low energy, order and disorder. Take away all the differences, and there's nothing left to experience anything with. Entropy is just the name for this process. It always increases in a closed system. The universe is the biggest closed system there is. It's been getting more disordered since the Big Bang, and it'll keep going until there's nowhere left to go. Bertrand Russell wrote about this almost 100 years ago, that everything humanity has ever built or thought or loved is destined to be buried in the rubble of a dying universe. He meant it as a provocation, like, if this is true, what does any of it mean? I don't think the answer is nothing, but I also don't think the question is one you can just dismiss. All right, 3 videos in, and I want to be honest about what I think the through line actually is. Bode's void. The universe is emptier than it has any right to be. The great filter. Something might be clearing the board before civilizations can fill it. And now this. Even if you survive, the board itself is temporary. These aren't 3 separate problems. They feel to me like 3 different ways of asking the same thing, which is, what does it actually take to matter in a universe like this one? here's the part that genuinely unsettles me. We're living in what cosmologists would call the Stelliferous Era, the age of stars. It lasts 100 trillion years. We're 13.8 billion years in. We are, cosmically speaking, incredibly early. The party has barely started, which means the choices we make now, not in 100 years, not in 1,000, but right now, in this century, are potentially setting a trajectory that extends across timescales no human brain was built to think about. Whether something recognizably descended from us is still around in 1 trillion years might actually depend, in some distant and non-linear way, on what we do in the next few decades. That's not a comfortable thought. We're used to thinking about the future in terms of election cycles and quarterly reports, and maybe, if we're feeling ambitious, the next century. But the universe is running on a different timescale entirely. And I don't think it cares whether we're ready to think at that scale or not. The question is whether we can learn to. Let me just put some numbers on the table, because I think it helps. 5 billion years. The sun expands into a red giant, and the Earth is gone. We'd need to have left long before that. 100 trillion years. The last new stars form. Whatever is still alive by then has to have found another way. 10 to the power of 100 years. The last black hole evaporates. After that, nothing. Thermodynamics wins. That's the final score. These numbers feel fake. I know they do. They're so large they stop meaning anything. But they're real. They're the actual boundary conditions of our situation. Everything we are, everything we've built, every person who has ever lived, it all happens inside this window. It's a very long window, but it does close. The universe started with a point of unimaginable energy, and it will end in a stillness of unimaginable emptiness. In between those two things, stars, planets, oceans, life, consciousness, cities, music, arguments, discoveries, mistakes, love, and us right now in the middle of all of it, trying to figure out what it means. I find that genuinely moving, not terrifying. Not because the ending is good, it isn't really, but because the middle is extraordinary, and we're in it. The light won't last, but right now, it's here. And maybe that's the only answer the question ever had.